Today we will discuss particle dynamics, and in particle dynamics we will discuss vertical circular motion. We will find the minimum velocity with which the pendulum should be projected so that it completes the circular path. This is what we intend to find. देखो यहाँ पे हमारे पास ये एक पेंडुलम है, ठीक है. The bob is having some mass. This is the length of the string. So let's write the mass of the bob as small m and the length of the pendulum as small l. Now we want to find out what is the minimum velocity with which the pendulum should be projected so that it completes the circular path. This is what we intend to find. So the pendulum should reach the topmost point. The pendulum should not slack in between, neither here in the first quadrant nor in this quadrant. So let's say that somehow the pendulum manages to reach this topmost point, and let's say that the velocity at the topmost point is represented as v. Now what happens if this v becomes 0? If this v becomes 0, this pendulum will fall straight away following this path. It will come back to its original position following the diametrical path, right? It is very important that this bob should have a non-zero velocity. इसकी velocity 0 नहीं होनी चाहिए. We will use the concepts of, first is circular motion to understand this problem. The second is conservation of mechanical energy. These are the two concepts which we will use while discussing this problem. So we have this pendulum here. It has some mass m, velocity is u. At the topmost point, this pendulum have some velocity v. This is the point of suspension O, and this is the string of it at the topmost point. Using the concept of circular motion, let's write the force equation at the topmost point. So this is tension T downwards, and the weight of the pendulum will be acting downwards. So what is the centripetal force acting here? Let's call the centripetal force as Fc, which is equal to T plus mg. This is the centripetal force. Okay, so T plus mg is equal to mass into v square over L. V square by L is the centripetal acceleration. Okay, now we have, this is one equation. Now conserving energy at the bottommost and the topmost point of the path. By energy conservation at A and B, we have at the bottommost point the kinetic energy is half m u square, which is equal to the total energy at the topmost point is half m v square, plus the gain in potential energy is the bob is rising along this line, that is the length is 2L, right? So the work done by the gravitational force is stored as potential energy, and it is equal to 2mgl. So this is the second equation which we have. Let's try to rearrange it. It is u square is equal to v square plus 4gl. Now this is the second equation which we have. Now let's discuss this equation. See, we want to find the minimum value of u. Minimum value of u is there for v minimum. U is minimum when v is minimum, because this 4 is a constant, g is a constant, and L is a constant. So the minimum value of u depends on what? The value of v. So minimum, then v is minimum, or if v is minimum, then u is minimum. But the value of v depends on what? See, this mg is a constant, but definitely this t can be a variable. See, we have these two equations. T plus mg is equal to mv square by L. The second equation was u square is equal to v square plus gl. Now we know that u is minimum if v is minimum, and v is minimum if T is minimum. So we have the minimum value of T in S not be negative. So the minimum value of T is equal to 0. So this is the minimum value of T in a string. This is the second equation. So we have, substituting the value of T minimum in the first equation, we have mg is equal to mv square by L, or we simply get v square is equal to g. This v is the minimum value of v. So substituting the value of minimum v, we have u square is equal to v square is gl plus 4gl, which is equal to 5gl. So we get the value of u square as 5gl, or simply the minimum value of u is equal to root of 5gl.